Okay, these the different types of polarized and polarized, non-polarized, and variable capacitors with their schematic symbol. The first one, it's polarized capacitors, where we have electrolytic capacitor, we have tantalum capacitor, we have tantalum siding capacitor, we have surface mounting device capacitor, and their corresponding symbols are three: this one and this one and this one. So the symbol of electrolytic capacitor, polarized capacitor, it can be this one with the positive sign, or it can be one end it's open, one end is closed, so the open end is positive. And this one, the closed or the shadowed end, is negative always. Or it can have this schematic symbol. Then another types of capacitor, these the different types of non-polarized capacitors. They don't have polarity. You can represent them, for instance, this one, this is electrolytic, this is ceramic, actually that from here, from ceramic, and that is polystyrene, and that is surface mounting non-polarized capacitor. So the symbol might be that one, so that one, so that one. But remember, the other ones does not have a positive sign to indicate the terminals, right? And then the last group of 14 is a group of variable capacitors. So this variable capacitor, they have two terminals, but they have also a set terminal, which we call the adjustment terminal, to adjust, actually allow to adjust the capacitance to the capacitor. So all of these are three examples of 14 variable capacitors. We don't use them oftenly in electronics compared to polarized and non-polarized capacitor, but it's better to know them. The schematic symbol of variable capacitors, you can see that this the symbol, one of the symbol, that one is this one, that one is this one. So you may use 8 of them actually in still representing the meaning. So whenever you find in the schematic circuit diagram, in the schematic analog circuit diagram, or less found in the schematic digital or logic circuit diagram, so actually that you have to understand that they represent the variable capacitors. So the aim, we are not going to cover about the variable capacitors, but we want to introduce into the mind of the students actually to know that, in the world of today, we have variable capacitors and they perform particular function. So if that's the case, thank you for this moment of demonstration. So once it is full charged, the capacitor acts as open switch to the DC power. So you might find that the information I'm giving you right now, it's more technical information compared to information that you had during your time of the science. Separating. We have a question here. What is the role? So we have a question. This is question number 4. What is a role of a capacitor in DC power? So we say that when DC power is allowed to flow through a capacitor, then a capacitor is charged with applied voltage within a short time until it becomes full what? Full charged. Right? Full charge. We call that full time, we call it time constant, if you do remember. In AC theory, in electromagnetism also, we used to teach A-level students about charging and discharging of the capacitor. For all level, we don't teach them about. No, yes, according to the static electricity, yes, we just teach them a little bit. So the means of charging of the capacitor and discharging what? The capacitor, because those are the fundamental keys. Because we say the capacitor store charge. How do we add the charge into the capacitor? That's a very important question. And then when capacitor store charge, what does it do? Okay, the capacitor discharge. So how do we take out the charges stored within the capacitor? That's what we call it, discharging. Are we together? So when DC power has been supplied through a capacitor, what is going to happen? That capacitor will be charged with applied voltage within a short time. You know the meaning of short time? Within a short time. Until it is what? Becomes full what? Full charged. And when it becomes full charged? It becomes full charged when the potential difference across, or when the voltage across the two terminals of the capacitor is equal to the supply voltage. Are we together? Every capacitor has its capacitance. Every capacitor has its rated voltage. Right? So for instance, if the capacitor has a voltage rating of 16 volts, say 16 volt. Say 16 volt. And then say 16 volt. And then you supply or you charge that capacitor by using the applied voltage of what? Of 10 volt. So the capacitor will be charged until, the potential difference across this terminal is equal to 10 volt from the supply. Right? By that time, the capacitor stopped what? To charge. So when it is full charged, or when it is, yes, when it is, so that by that moment you say that the capacitor is full what? Full charged according to the applied what? Voltage. So when the capacitor is full charged, then the capacitor acts as open what? Open switch. That's why we say that the capacitor does not allow the DC voltage to pass through it. Let me clarify this concept, then we move on. Let us take considerations of electrolytic capacitor. Say electrolytic capacitor. Say electrolytic capacitor. So electrolytic capacitor, when you say electrolytic capacitor, let us take an example of this one. So this electrolytic capacitor, which is capacitance 470 microfarad and voltage rating 63 volt. So this is the demo or clarification. Its voltage is what? Its capacitance is 470 microfarad. If you are a serious student, you do remember that in resistors, I talked about standard resistors, right? Also in capacitor, we have also standard what? Capacitors, right? Expect something like that. Then the rated voltage for this one is 63 volt. That's the voltage rating. Are we together? And then this capacitor, it has two terminals here. One terminal, it's negative, the other one is positive. I will teach you in workshop 5/2, right? Workshop 5.2 or 5/2. Because this is workshop 5/1 or workshop 5, yes, workshop 5.1, 5.2. So 5.2 I will teach about that one, right? You suppose that you want to use this capacitor as a filter to filter a linear power supply, right? A linear power? A linear power supply. So if you want to use this capacitor as a linear power supply, and hence you have used a step-down transformer of, let's say, 24 volt, or 12 volt. So 12 volt, you know the maximum voltage is what? 12 volts times what? Root means times what? And out of 2, right? Which you use to find 16.96 volt, right? And then we have a potential drop of 1.4 volt in the bridge circuit. Do you remember that? So you usually remain with, let's say, 15 volt. So suppose that here you have your source of DC source, positive, this is negative, and this is positive. You have your DC source, and the voltage it's 15 volt. Right? But these are what the maximum rated voltage, 63 volt. So it means that once you turn on your circuit within a short time, this capacitor will be charged until the potential difference between negative and positive terminal is equal to applied voltage, which is 15 volt. By that time, so by that moment, you say the capacitor is full charged. So when it's full charged, for instance, if you say that this is your DC, so it means that this is your DC source, negative, positive, you're being charged. During the charging, just remember that the current is just flowing within the capacitor itself. Within the capacitor itself. So this is 15 volt. So once it is full charged, then the capacitor acts as an open switch. Act as open what? Open what? Open what? That's why that we cannot have a DC and say that with this DC, so the DC will be flowing through the capacitor. No. Why? Because once the capacitor is full charged, the capacitor acts as open what? Open what? And I gave you a reason. Why? Because the frequency of the C signal, it's 0 Hertz. Then the capacitive reactance of the capacitor for that case is 1/2 pi FC. So then capacitive reactance of the capacitor is 1/2 pi. The frequency is 0 times capacitance. The answer is infinity. Right? So for this one, for this case, it means that capacitive reactance for the capacitor against the flow of DC is what? Infinity. That's why that there is no any flow of DC voltage through the capacitor to other side. If this is positive and this is negative, here you have this, you have your DC voltage, it will never cross to the other side. Why? Because the capacitor acts as the open OT switch. Why? Provide infinity OT resistance. But for the AC, the frequency of AC, frequency of domestic AC in Tanzania is 50 Hertz. Right? Right, Farid? We are trying to just to challenge you. Capacitive reactance is what? 1/2 pi. Times what? Frequency is what? 58. Times what? Capacitance. So if you know the capacitance, we just replace 470 microfarad. You can know the capacitive reactance of this capacitor against the flow of what? Of AC. Physics is beautiful, electronics engineering is beautiful, and electrical engineering is beautiful. Isn't it? Huh? Huh? Okay. So the class is quiet. So now, let us move on with working principle. Working principle of a capacitor. How does a capacitor work? So with that question now, you might get the answer about what I've been teaching you about how does a capacitor charge itself. So we have question number 5. This is number 5. How does a capacitor work? How does it store charge? Or how does it gate and store charge? Very important question. So here it's the working principle. It's simple. Whenever voltage is applied across its terminals, current starts to flow. Current starts to flow and continue to travel until the voltage across both the negative and the positive, negative and positive, or anode and cathode in case of electrolytic capacitor, anode and cathode. Again, in positive plates become equal to the voltage applied voltage. So this is the principle of charging. So say whenever, listen, separating. Whenever voltage is applied, whenever what is applied across its terminals of what? Of a capacitor, then current starts to what? To flow and continue to travel until what? Until the voltage across both negative and positive plates become equal to the what? Applied voltage. So this process is called the charging a capacitor. Charging what? Charging a capacitor. Say charging a capacitor. Say charging a capacitor. So this process is called the charging a capacitor. So if you do remember that, we used to say that we have a formula that's called the quantity of charge is equal to what? You forgot. Maximum quantity of charge, open bracket, 1 minus what? E, power what? Power negative T over what? RC. What is this? Instantaneous quantity of charge. What is this? Maximum charge. What is number 1? What is this? E. 2.17 or 2.7 or 2.71, something like that. This is what is time. We call it time constant. And what this one? Resistor. What this one? Capacitor. You forgot it. Why you forgot it? Because you passed the next exam of advanced physics, and now you are college students and learning engineering. So this is the formula that guiding what? Mathematical formula guiding charging what? Charging the capacitor. So every capacitor has its maximum quantity of what? Of charge. So to know the instantaneous charge, and you do remember, we say that engineering is all about numbers, formulas, and mathematical equation. Then what? Tables, diagrams, and graphs. You forgot. Let me remind you, it's a graph. Its graph is actual time, and here we have what? Voltage. You forgot. And here we have something like this. So this is what? So at this point, we say that this is Q, quantity of charge per unit time. So this we call Q naught, maximum quantity of charge. Hey! So this is the graph of 40, charging of the capacitor. So this is the mathematical equation for 40, charging the capacitor. This is what? The graph. So this is what you call what? Time. You forgot. Okay. Good. So then that is all. That's the simple principle. So it means that the capacitor can be charged if there is a supply of 40 external voltage. When you supply the external voltage and the capacitor is uncharged, the capacitor starts to charge because the current will be flowing from the positive to the negative and circulating within the capacitor. When the charge will be received within the capacitor within a short time. Once the potential difference across the two terminals of the capacitor is equal to the potential difference across the is equal to the potential difference of the source, then the capacitor is full charged by that time, right? Then we come to another phenomenon that's called what? Discharging. Say discharging the capacitor. So discharging of the capacitor is actually using the electric charge or the electric energy stored within the capacitor, right? How does the capacitor discharge? It's simple. You just connect the capacitor with the load, and then the capacitor discharge to cause the flow of electric current. And the discharging also is within a short time, but depend the capacitance of 40 of the capacitor, and depends also the amount of the current that the load draw. If the load draws small amount of current, yes, the capacitor can discharge even within an hour. Are we together? Are we together? Eh? Class, are we together? Okay, so discharging. So that's another principle, discharging of a capacitor. It's very simple to discharge a full charged or a partially charged a capacitor. How? You just connect a capacitor with the load. You just connect a capacitor with the load. So when you connect a capacitor with the load, a capacitor discharge. So you say that when we connect a capacitor, a charged capacitor, when you connect a charged capacitor, when you connect a charged capacitor across a small load, across a small load, we say that it starts. So this capacity starts to supply the voltage. Or store the energy during charge, store the electric energy during charge to that load. Until so start to that one until the capacitor is full discharged. Till the capacitor is full discharged. So you say that when we connect a charged capacitor across a small load, it starts to supply the voltage. The capacitor starts to supply the voltage to that load until the capacitor is full discharged. And remember that when you say a small load, sometimes you are the human being. You might be a very good example of load. So you just discharge a capacitor, but I don't advise you to do so, especially for the supercapacitor. But for this one, the thing is, actually you might not think. I think that it's better to have a supercapacitor. So you just see full charge and then you short the two terminals like this. You enjoy the moment because you'll be a load. So the current within this capacitor will flow through your body and it will be completed. Right? So in sense what? Electric shock. Class, are we together? Yeah, so that is the principle of 40, the principle of capacitor. That the principle of 40, principle of 40 class of capacitor. Okay, so then let us end this lecture, this workshop by covering the concept of categories of the capacitor. Categories. Say categories of the capacitor. Again, say categories of the capacitor. Again. So he said that in electrical and electronics, what? Engineering. Like you, there are 3 categories. 3 categories of 40 of capacitors. Namely, first one, we call it polarized. Class A, polarized. Say polarized. Polarized capacitors. The second category, we call it non-polarized capacitors. And the third category, we call them variable capacitors. So there are 3 categories of capacitors. The first one is class A polarized capacitors. If you pronounce them, so you keep them in your mind. Say polarized capacitor. The second one is called the non-polarized capacitor. Say non-polarized capacitor. And then the third category is called the variable capacitors. Say variable capacitors. So let me introduce to you about each category, and then it will be end of our workshop 5/1. So let me introduce to you about polarized. Polarized capacitor. And then let us have question number 6. What is polarized capacitors? We are transforming you from your scientific knowledge of capacitors into electronics and electrical engineering knowledge of 40 of capacitors. So what is polarized capacitor? So you say that a polarized polarized capacitor is the type of capacitor that has positive and the negative, that is positive and negative terminals, negative and positive terminals, to allow the flow of electric current in only one direction. So you say that a polarized capacitor is the type of capacitor that has a positive and negative terminals to allow the flow of electric current in only one direction. In only one direction. So it does not allow the flow of electric currents in two directions, or just allow the flow of electric currents in only one direction. Examples. Or before example. So polarized capacitor, it has two, it has a positive terminal and a negative terminal. So the currents will be flowing from positive terminal towards the negative terminal of the capacitor. So examples of polarized capacitor are aluminum electrolytic capacitor, aluminum electrolytic capacitor. Second one is called the tantalum electrolytic capacitor. Tantalum electrolytic capacitor. Say aluminum electrolytic capacitor. Class A aluminum electrolytic capacitor. The second one is, say, class A tantalum electrolytic capacitor. Huh? Tanta? Huh? Again, say tantalum. Uh-huh. Uh-huh. Okay, practically, or according to electrical and electronics practical, polarized capacitors are not used in AC power. Means that they are not used in AC power. Polarized capacitors are not used in AC power. Why? Polarized capacitors, most of them are used in DC power. But remember that they are not used in AC power. It means that they are not used in the circuit where the only AC power is just flowing. Question number 7. Why polarized capacitors are not used in AC power? Why are not used in AC power? So the name itself says that polarized, so it means it has two polarities. Positive polarity and negative what? Positive polarity and negative polarity. So because it has two polarities, positive polarity and the negative polarity, while AC does not have polarity. AC, alternating currents, alternating voltage, is just alternating, right? It has a half positive cycle and a half positive cycle and a half negative cycle. Half positive cycle and actually it alternates in what? Just in fraction of a second, because it completes 50 cycles within 1 second. Okay? So why? Can you take 30 seconds to think? Try to ask yourself why. If you've understood the concept of capacitor. So say polarized capacitors. This is the reason. Polarized capacitors are not used in AC power. Why? Because the reversal of polarity, of current after each half cycle in AC affect the capacitance of the capacitor. That leads to damage. Separating. So polarized capacitors separating are not used in AC power. Why? Because the reversal of polarity of current, of AC current, after each half cycle in AC affects the capacitance of the capacitor. That leads to damage. Why? Remember, polarized capacitor has two polarity: positive terminal, and negative terminal. While AC, which it's a signal that will be flowing through the capacitor, does not have polarity. Right? It just alternates its polarity. So that alternations of polarity of AC affect the capacitance. Remember that what the capacitance? Capacitance is the ability of the capacitor to store charge. Or capacitance is the measure. Remember that I gave you one definition, that capacitance is a property. Right? It's a property of what? Of a capacitor material to, which defines as what? Ratio of electric charge to the what? Electric charge on the conductors to the potential difference. Right? But in other words, we can define the terminology capacitance as capacitance is the ability of what? Of a capacitor to store charge. Or capacitance is the measure. Why it's a measure? For instance, we had a capacitor which its capacitance is 470 microfarad. So that 470 microfarad is it's a measure of how much charge can that capacitor store. Are we together? So if the capacitance is affected, actually can damage what? Why? Because remember that when you say polarized capacitors, most of polarized capacitors are fixed capacitors, or are the capacitors which have a fixed value of capacitance. They don't have even tolerance, just like in case of resistors, right? So it means that if just AC is allowed to pass through them, it will affect what? The capacitance. Once it affects the capacitance, it can affect the capacitor itself. Are we together? So that the reasons why these electrolytic polarized capacitors are not used in AC. So you say that the polarized capacitors are only used in DC power system. DC power system. Are used in DC power system only. Then let me introduce to you, because I'm introducing to you. In the next workshop, we'll just go in detail, especially for polarized capacitors. This is what we are going to cover in Fundamental of Practical Electronics. Listen, we are going to cover polarized capacitors in Fundamental of Practical Electronics Engineering. And then in what? Possibility in Intermediate of Practical Electronics Engineering, we'll cover non-polarized capacitors. Right? Yeah. So number 2, we say that we have what? None, but I am responsible to introduce to you non-polar non-polarized capacitor. Non-polarized capacitors. Question 8. Define a non-polarized capacitor. A non-polarized capacitor is a capacitor which does not have positive and negative terminals to allow current to flow. Through it in one direction. But it allows current to flow in both directions. So simply this is the vice versa of a polarized capacitor. So they don't have two, they don't have, actually they have two terminals, and a polarized, you say that that does not have positive and negative terminals. They have two terminals. Remember that from the fundamental definition of a capacitor. What is a capacitor? A capacitor is a passive two terminals, right? Electrical or electronics component that store what? Electric energy in form of what? Electric fields. Are we together? But these ceramic capacitors, because for instance, let me show you some examples of ceramic capacitors. So this is the ceramic capacitor. Now this is the non-polarized capacitor. And this is another non-polarized capacitor. And this one also, it's a non-polarized capacitors. So these are the non. So you have them. For the local students, I have given you. All of the capacitors are of this shape. So you can check yours. So these are mine. So you can check, and then so you understand, you check yours. So these are ceramic yoti. These are non-polarized capacitors. Say non-polarized capacitors. Say non-polarized capacitors. So in these non-polarized capacitors, they have two terminals. But for these two terminals, none of them which is positive and none of them which is negative. In case of electric capacitor or polarized capacitors, there's also two terminals. These are the two terminals. But one terminal is negative, the other terminal is positive. So this is positive, and this one is negative. But for this case, we have neither positive terminal nor negative terminals. But they are two terminal passive electrical electronics component. So for that case, this capacitor will allow electric current to flow only in one direction, from the positive terminal towards the negative terminal. This is polarized capacitor. For these non-polarized capacitors, they allow the flow of current in both directions. What does it mean about both directions? It means we can have, that the flow of currents might come from this direction to this direction. It means that from this side to this side, or from this side to this side. Right? Right? That's the meaning of both direction. So for these ceramic capacitors, or these polarized, we call them polarized capacitors. Sorry. Yes, I mentioned them ceramic because ceramic capacitors are the common one they are using in electronics. Right? So the non-polarized capacitors, these are non-polarized capacitors. This is polarized capacitor. Here it's a polarized capacitor. This is non-polarized capacitor. These allow currents to flow in one direction. These allow currents to flow in both directions. Right? This has positive terminal. This don't have positive terminal. This have negative terminal. This don't have negative terminal. But remember, all of them, they have the electric material and two conductors, or two plates. Are we together? Are we together? So for the ceramic, for the non-polarized capacitor, you should not bother about the polarity. Right? But for this one, the polarity is very important, because if you reverse the polarity even in DC, you are going to damage the capacitor. Right? If you have any question, don't hesitate to ask. So if you have understood the definition of non-polarized capacitors, then let me now give you some examples of non-polarized capacitors. So to extend your knowledge, or to extend your understanding or your comprehension. I know that in O level and A level, mostly you learned about polarized capacitor, right? So in college or in institution or university level, we have also to teach about non-polarized capacitors. But even polarized capacitors in O level and A level, you learn them theoretically. You've never used them, you've never connected them to the maybe to AC power and see what happened. You've never connected them to the DC power and see what happens, isn't it? Eh? So just learn them theoretically, and then. So examples. Examples. So the following are the simple examples of of polarized capacitor. The first one is paper capacitor. Paper capacitor. Say paper capacitor. Say paper capacitor. Say paper capacitor. The second one is called the mica capacitor. The third one, we call it ceramic disc capacitor. Then the fourth one, we call the polystyrene. This is the organic capacitor, which is used actual the organic organic material as what as electrolyte. So these we call them what polystyrene capacitors. So these are the simple example of non-polarized capacitors. So we have paper capacitor, say paper capacitor. We have mica capacitor. We have ceramic disc capacitor. We have polystyrene capacitors. The goodness of this capacitor, their physical appearance differ. Their physical appearance what? Their physical appearance what? Differ. Their physical appearance differ. And let me show you. Because it's better if you see the picture. Whenever you find them, you understand that these are polystyrene, or these are mica capacitor, or these are what? Paper capacitor. Okay, so this is the image of paper capacitor. Paper capacitor as example of non-polarized capacitors. So they can have different colors, but this is the one of the common color. So just enjoy it and keep in your mind. Okay, so this is the collection. So these are the example, or it's the image or the appearance of 40 mica capacitors. So whenever you find them in the motherboards of electronic circuit, I think that you will enjoy them, and this is how they look like. And they have a particular functions in different electronic circuit. Okay, so this is the physical appearance of 40 of ceramic capacitor. So these are the ceramic capacitor, 104 ceramic capacitor. It has the meaning that number 104. And actually they are small in size, very interesting capacitors, but they have a higher voltage rating compared to even electronic capacitors. But you see, they have two terminals, none of the terminal which is positive and none of the terminal which is negative. It means that they can just allow the flow of current in either direction. So that's all. Enjoy it. Whenever you find it in most of electronic circuit, then tell them you are ceramic capacitor and I know you. Okay, this is the physical appearance of 40 polystyrene capacitors. Polystyrene capacitors, because we have organic capacitors, so we have polystyrene capacitors, which is select materials, say organic compounds, as you've been learning about, aromatic compounds, you've been learning about alkane, alkane, alkyne, all of those stuff that sample can be used as what are the electric materials to make a capacitor. These capacitors look very nice, and you can find in the motherboards of computers, motherboards of flat screens television, and actually that you have to bear in your mind that whenever you find them, those are polystyrene capacitors. They are non-polarized capacitor. Enjoy it. These are the 4 examples of non-polarized capacitors. So let us end our workshop 5/1 with the third category, which is variable capacitors. Variable capacitor. Variable, class A, variable capacitor. In case of resistor, we also have a terminology we call it variable resistors. So here we have a question. What is a variable capacitor? What is a variable capacitor? So a variable capacitor we say that is a capacitor whose capacitance whose capacitance may be intentionally and repeatedly changed mechanically or electronically. So a variable capacitor is a capacitor whose capacitance may be intentionally and repeatedly changed mechanically or electronically. So we can change, so instead mechanically, we can have a screwdriver. Do you know screwdriver? And change its capacitance. That's the meaning of what? Mechanically. Electronically, it means that we can have a switching circuit, or just, we don't call it a switching circuit, but just an altering circuit. So altering circuit is the circuit that whenever we have a particular signal, and then you find that itself, it can change its capacitance. And that is special, for instance, when you say electronically, let's say electronically. For instance, have you ever seen how do we use to align the television dish? Sometimes you just use the dot there, just you use the commands or use the remote, right? And then when you press that remote, you find that the antenna, the dish antenna, actually aligns itself in the maximum gain or in maximum regions where the signal from the satellite is strong. Are we together? So that is no longer mechanically, it's electronically. You're using an electronic circuit actually to rotate the dish on the top of the roof of your house. Are we together? Yes, so that is the meaning of 40 variable capacitor. So again, we say that variable capacitors are often used in LOC, /circuits, to set the resonance frequency, to set the resonance frequency, to say the resonance frequency. And here are the examples. Set the resonance frequency, example for example. Say resonance frequency. If you want to tune a radio in particular frequency, to tune a radio, you may use variable capacitor. Also, we tune the resonance frequency to vary the reactance, capacitance reactance for impedance matching. For impedance matching. For impedance matching, in antenna tuners. In antenna tuners. Antenna tuners. Okay, so this is the end of our workshop 5/1. Thank you very much. May God bless you. But the homework is why non-polarized capacitors are used in both AC and DC power. Listen to the homework. Why non-polarized capacitors are used in both AC and DC power system. At the end of workshop 5/1, I invite you in workshop 5/2, when we are going to learn about polarized capacitor. And we are going to learn about aluminum and tantalum electrolytic capacitor, which are often used in electronics. Thank you very much. It seems like it is night. Bye-bye. See you in the next workshop.